Hi my dear friends, this is a video belongs to GATE examination and some other competitive examination for electronics and communication diode basics problem we are going to discuss. Okay, the first problem is, see there, one diode circuits with one potential, then one resistor with 0 grounded load power and 5k resistors. This series belongs to 5k. So we are going to find the V0. So the circuit is belongs to a silicon diode. Okay. So for this problem, already everyone knows the basics concept. So the problem the given the silicon diode is, we need to consider 0.7 voltage for barrier voltage. Yes. So for that reason, I am going to simplify. The given input voltage is 12 voltage. Okay. For that reason, I am going to simplify these circuits with the help of voltage principle. Okay. So now we are going to identify what is meant by V0. After that, we are going to identify current. Okay. There are two parameters we are going to solve. So the V0 belongs to, see there, 12 voltage minus 0.7 voltage. It is equivalent to 11.3 volt. Okay. From the given data, the resistance are given. So we are going to solve current for the particular diode. So current for the particular diode, already we know according to the Ohm's law, V by R. Okay. So here 11.3 divided by over by 5 kilo ohms resistance. So finally we are going to get, as per the value, so some current will flow here. Okay, some current will flow here because the diode circuit is considered as a forward bias. Okay, and also the answer will come based on that milliampere. So how much value will come for this? So compare with another circuits. I am going to do another circuits. So see that the same circuits I am going to give like a different direction of the transform and our diode. So some voltage barrier also there, voltage also there, 9 voltage. This is also given silicon diode. So here some value will come. Okay. Now according to our diode direction, see here the positive terminals are connected to the negative terminal. Here the negative terminals are connected to the positive terminal. That means diode under reverse bias. Diode under reverse bias. That means our output voltage V0. So V0 equal to 0. So automatically, if it is V0 equal to 0 means, I also 0. That means that the diode is off circuits. Here we are going to get some I value. Yes or no? We are going to get some I value like 11.3 voltage over 5k. Okay, so we are going to get some I value. That means the diode is on. So that simply, I am not going to solve everything. So the concept is the diode is on or not. Okay, so some current will flow. That means that it is a forward direction. So we are going to get diode is on. Automatically we are going to get current value. Okay, so this is some basics problem only. So I am going to do another problem. I am going to connect two diodes here. So here 1 kilo ohms resistance. So as usual, this is for V0, and then so 9 voltage of the given input voltage. So this also connected like a zero potential. So this silicon is called it as silicon diode. This is called as germanium diode. Now just you applied according to the Kirchhoff voltage law. Just you applied. Okay. So now we are going to get 9 voltage minus silicon. How much voltage drop? Across voltage drop. This across voltage drop is 0.7 voltage. That everyone knows. Yes or no? So 0.7 voltage minus. So across this voltage drop is VD 0.3 voltage. So 0.3 voltage. Finally 8 volt. Finally 8 volt we got. That means I equal to 8 volt over by 4k. So this is for input is 4k. So 8 watt over by 4k. Finally, how much we are going to get? So we are easy to solve. I equal to 2 milliampere. So we need to mention as a milliampere because the air current always in the forward direction as in milliampere. Okay, in the reverse direction in microampere. That is means that's what we, that is for that reason it's a negligible value. Okay, I'm going to solve another diode. Okay, I'm going to solve another diode problem. These all are basic principle of the diode. So here one diode I am going to connect. Here one diode I am going to connect. The same thing, germanium, this diode is belongs to germanium, this diode is belongs to silicon and germanium. So the voltage is 6 voltage, and then here V0, the resistor value is 5 kilo ohms resistance. So in this session, finally we are going to conclude what is the basic concepts we are going to apply in the diode circuits. Okay, so now you can check. There are two diodes. There are two diodes are there. Okay, so here the 6 volt will travel from here around the germanium. This 6 volt travel around the silicon and the germanium. We will get different output voltage. So automatically the silicon means here we are going to get 5.7 voltage. If it is a 5.7 voltage, like this value 5.7 voltage, this node will come. So here 5.3 voltage, here 5.7 voltage. So here we are going to change immediately. This diode only going to conduct. So already everyone knows. So because of the less barrier voltage, this diode going to conduct. So from this, how much voltage we are going to get here? 5.7 voltage. Immediately we are going to get 5.7 voltage. From this, we are easy to possible to solve current value. I equal to 5.7 over. So how much resistance is given? 5 kilo ohms resistance is given. So automatically we are possible to get I value. So how much current will flow here? So here the current will flow approximately 1.1 milliamps. Okay, 1.1 milliamps. So this is the circuits. So these all are basic circuits based on the diode. So I'm going to use another circuit also. These all circuits are belongs to diode circuits only. Okay, so now I'm going to use with another new components, resistor, one diode, and then output, and then 4 kilo ohms resistance, and then some barrier voltage, 10 voltage. So automatically here 3 kilo ohm resistance is there. This is also given ideal diode, voltage drop also there. So automatically you can find easily this voltage drop is belongs to I equal to 9.3 voltage over actually these two resistance are there because they given forward resistance also. In the circuit they given forward resistance and also load resistance also given. So for that reason we are going to add these two resistance. So finally 7k. So this circuit is belongs to diode circuit only with the help of forward resistance. So they given forward resistance also. Finally we are going to get 1.33 milliampere current. 1.33 milliampere current. But the voltage, sometimes they will ask another question also. Voltage across 4 kilo ohms resistance. So automatically 1.33 into 4 kilo ohms. Finally 5.32 voltage will come across this resistor. Okay, that's all. This is a very basics problem. So next lecture, next lecture video, we are going to discuss about some other problem related to diode circuits. Okay, if you have any doubt regarding this problem, you can in the comment box. We will discuss in the final discussion. Thank you all. Thank you once again. We will see in the next video soon.